we're going to be talking about the properties of logarithms, and this is kind of a bigger section. There's a lot of different concepts we're going to be looking at. And so first of all, this is taken from your book. We have the 3 properties of logarithms. Okay, basically what you need to understand here is that if you multiply a quantity here, you can split that quantity up by addition. If you divide a quantity, you can split it up by subtraction. And then if you have a power with a logarithm, you can get rid of that power by moving it out front and making it a coefficient. And that's probably not going to make a whole lot of sense until we look at a few examples. Okay, but this is what you're going to have on the first part of your homework. It says express each logarithm in terms of ln2 and ln3. And this is the thing. On that first slide when it says properties of logarithms with log, that also applies to the natural logarithmic function as well. Those are interchangeable. Okay? So now this is the thing. In my answer, I only want to have ln of 2 and ln of 3. So I need to think, how can I write 54 using only the numbers 2 and 3? So let's go ahead and start. So 54 I can only write using 2 and 3. So how can I write 54 using only 2 and 3? 2 times what? So 2 times 3 times 3 times 3. You agree that's 54? Okay. All right, and so basically what ends up happening here is that means I've got the natural log of 2 plus the natural log of 3 plus natural log of 3 plus natural log of 3. Why did I add those natural logs together? Because of the timesing. Exactly right. And we're about done. I can simplify because I have this, this, and this. Okay, so really when you think about it, how many ln3s do you have? 3, so it'd just be 3 ln of 3. And there you go. Okay. Another way you could have done that is you could have done that as ln of 2 times 3 cubed. And then when you would have split that up, you could have moved that 3 around front, and you would have gotten the same answer. So let's look at the next one. It says ln of 9/8. So once again, the only numbers I can use are 2 and 3. So what do you know that is? Okay, so can I do 3 squared just to show you how to do a power? And then over what? 2 to the 3rd. So really what this means is this means ln of 3 squared and then what? Minus, very good, ln of 2 cubed. And you're about done except for now you have a power, and so I'm going to get rid of that power. So how do you get rid of that power from the first slide?
L and 3L.
Equals P log B.
Yeah, P log B. So basically I'm taking that 2 around front. So 2 ln 3 minus 3 ln 2. Because I take that power and I move it around front and make it a coefficient. That's the answer. Okay. So let's go ahead and look at another one. Log of 75. This one isn't ln of 2 and 3. I think this one is log of 5 and log of 3. Okay? This one is log of 5 and log of 3. Okay? So go ahead and do that for me, and then tell me what you get. Okay, so go ahead and get the final answer.
So we pretty much use log instead of ln.
What does it mean, like log 5, log 3? What's that saying?
Those are the two numbers you're using instead of, on the previous slide it was ln of 2 and ln of 3. On this one, I want you to use, for log of 75, only log of 5 and log of 3.
Oh,
Okay, so it's
Yep.
an and symbol.
Yeah, that's an and symbol. Okay. You aren't going to be able to write it using 2 and 3, so that's why.
I got log 75. I'm not doing No.
Okay, so real quick, what'd you get 75 to be? So basically, log of 3 times 5 squared, right? 3 times 5 times 5. So you should have gotten your final answer to be log of 3 plus 2 log of 5. You could have also had the 2 log 5 written first and put plus log of 3 as well. So let's look at that next one, that one on the bottom. Now this is a little different because you're probably wondering, how do we do that with just 5 and 3? And the answer is carefully. First of all, I'm going to write this as a fraction. So I know that 5.4 is actually 5 4/10, right? Which is really 5 2/5, right? Which is really what?
What is it?
What is 5 2/5?
27.
27 over 5. So instead of it being log of 5.4, I'm going to use log of 27 fifths. So do you see how by manipulating that we've now made this a lot more manageable of a problem? I want you to go ahead and do that as well. This one's the log 5 and log 3 as well. Okay.
Isn't that how you write it in the division?
Oh.
I like logs.
So really what you should have gotten is log of 3 cubed over 5. So final answer, 3 log 3 minus log 5. Okay? Alrighty. So let's go ahead and look at this. It says evaluate each logarithm. And so we're going to be utilizing some of the stuff that we've already learned through sections 1 and 2, and we're going to be building on these. And these are a little bit more difficult. But if you've got a good base, you should be fine. Now, if you remember, what ended up happening, I want to have something like this happen, 4 to some power, right? Because what happens to the log base 4 and the 4? They cancel, and that leaves me with whatever's in the circle. Okay, so that's the case over there. So I need to figure out, how can I write this right here as a power of 4? So first of all, let's go ahead and simplify that down. That's really log base 4 of 64 to the 1/5, right? That's what that little 5 means outside of the root. Okay, now my whole goal is to write 64 to the 1/5 as a power of 4. What is that as a power of 4? 4 cubed. And I'm going to raise that to the 1/5 power. So really, what does that simplify to be? The 3/5. So what's your answer going to be then? 3/5. Okay. Okay. Now let's look at the next one. Now see, the thing with logarithms, I can show you examples, but every problem is different and how you solve every problem is different. Okay, so let's look at this next problem because this next problem is different. Can I simplify this as it is at all?
No.
Really? What do I know about ln and e? They cancel.
Oh, never mind.
So really, what does that become?
5 times 2.
5 times 2. Good. Minus.
Oh.
Minus 3.
Oh my gosh.
What's your answer?
7.
7. Okay. So far, so good?
That's so easy.
Okay, so let's look at this one. Log base 6 of the cube root of 36. So our goal here is going to be to write the cube root of 36 as a power of what? 6. Very good. So really, this is log base 6 of 36 to the 1/3. Which is really 6 squared. Good. And I'm going to raise that to the 1/3 power. So I have log base 6 of 6 to the 2/3. So what is your answer? 2/3.
So always with that little number, because what are you doing? Because the log is
So now we're going to expand each expression. We got 2 more things we're going to talk about. And then we'll stop for today. Okay. Yeah, I'm going to cover change of base tomorrow. What does expand mean to do? Make bigger. Okay, so basically I'm starting with one singular term and I'm wanting to expand that and make it bigger. So I'm going to be applying all those properties that I looked at on the very first slide. So things you're looking for powers, you're looking for multiplication, and you're looking for division. Okay. So what I'm going to do first of all is I'm going to go ahead and split up the multiplication. So if you notice, there were three terms. There was a 12, an x to the fifth, and a y to the negative second. And so I split those into three specific logarithms. Remember what I told you to look for? Multiplication, division, and what else? Powers. I see I've got some powers, right? What do I do with those powers?
You move in the front?
Move them to the front. So move those to the front, and then that's it. You're done.
Really?
Yes. Log of 12 plus 5 log of x plus negative 2 log of y. And there you go. When all is said and done, you shouldn't have any multiplication, division, or powers. So let's look at the bottom one. So can somebody tell me what I'm going to write first? What? Yep, ln of x squared. Keep going. Minus
ln of 4x. Why is there
There you go. Reason why we use minus is because we had division in our original problem. So division, remember, implies subtraction. So now, really, real quick here, so I don't have to take up a whole nother line.
all you have to do is
This is really 4x plus 1 to what power? The 1/2. Remember, squared is the 1/2. So now, what would my next line in my final answer look like? 2 ln x, yep.
minus 4x.
1/2 ln of 4x plus 1. Okay. So that's expanding, making bigger. It's the opposite of expanding. Compressing, close. Okay, condensing, and we'll get to that shortly. Okay, we've got one more that I'm going to see if you can go ahead and get down. This is still expanding, yep. So let's go ahead and we'll look at this one. It's really not near as bad as it looks. This one's probably going to take us about 3 steps as opposed to 2. So I've got the ln of 3y plus 2, right? I'm going to subtract from that the ln of 4y to the 1/3. Okay, do you see where the 1/3 came from? Okay, we've got a 4 and we've got a y to the 1/3 in the denominator. So now real quick, I've actually got another step I need to do before I can even deal with that 1/3. Minus, I'm going to now have to split up those two. So I'm going to use a parentheses. And I'm going to let you write that down and look at that and see if you understand what I exactly did there. Because it's multiplication with the 4 and the y. So that's why I used a plus sign. Now, you would not have to use parentheses if you would do what?
4. If you would have made 3.
If I would have made this minus here, as well as this minus. Okay, if you would have distributed that negative. I like to leave it in parentheses though, because I just kind of think it makes a little bit more sense to me. What else do you have to do in order to get a final answer? Move the 1/3. And there you go. So that one wasn't too much more difficult than the ones we did. All right, condense. The last thing we're going to look at today, and then tomorrow we'll pick up with the change of base formula. Okay? So we went to expand, which meant we started from 1, got bigger. We're going to start from bigger and get to 1. Now this one, things you're looking for. Remember originally, things we looked for were multiplication, division, and powers. Things we're looking for now are coefficients, subtraction, and addition. And we're going to have to undo those. Coefficients mean that we're going to now make powers. So I'm going to take that 4 and I'm going to move it up to the x. I'm going to take that 1/3 and I'm going to move it up to the x plus 6.
Are we done?
No. So really, I've got log base 3 of x to the 4th, right? Minus log base 3 of x plus 6 to the 1/3 power. So remember what I said we're worried about. Coefficients, addition, subtraction. Notice here I've got a subtraction sign. What does that mean I'm going to do with the x to the 4th and the x plus 6 to the 1/3? Divide. Yep. So I've really got x to the 4th over x plus 6 to the 1/3. Now you could write that as the cube root of x plus 6 if you wanted to. But you don't have to. Yes. And if it's addition, you change it to multiplication. So let's go ahead and look at that second one. We'll see if that second one goes a little bit easier. What's the very first thing, as you're writing that down, I want you to think, what's the very first thing you're going to do? Move the 6. So really, ln of x minus 4th to the 6th plus 3 ln, oops, plus what? Yeah, we got to move the 3 as well. So it'll be ln of x cubed. What's the next thing you do? Put what? Multiplication, because it is addition. So it'll really be x minus 4 to the 6th power times x cubed. With the condensing, you only have one logarithm at the very end. You're only going to write logarithm or ln once. Okay. Now what's going to happen is tomorrow we're going to cover the change of base formula, okay, which isn't going to take us very long, but you can go ahead and get started on your assignment, page 185. 2 through 16 the evens, 20 through 36 the evens, and 40 through 46 the evens. Okay?